Right, good day and welcome. I'm Mr. Simons. In this lesson, we'll be looking at different ways to prove that a quadrilateral or four-sided shape is a cyclic quad. Right, so in exams, we will ask you to prove items as cyclic quads. And this here to prove, we can only use theorem 4b, 5b, or 6b. So first, we would give you a shape. It can be in a circle or given separate like this. You have to prove that I'm able to draw a circle that to touch A, B, D, and C. It will touch the circle at the circumference. So first, if you look here, theorem 5b, ABC is a cyclic quad, provided I can prove that angle A plus angle D equal 180, or angle B plus C equal 180. My reason why it would then be stated as a cyclic quad is that the opposite angles are supplementary. Then we can also test you via theorem 6b. I'm going to use the converse of exterior angle equal interior opposite angle. So for ABCD to be a cyclic quad, I have to prove that angle D2, the outside angle there, must equal the opposite interior angle. And my reason would be stated why it's a cyclic quad: exterior angle equal interior opposite angle. The last one, when you see a X in a shape, we're always generally working with theorem 4b, right? And here, for ABCD to be a cyclic quad, I have to prove that C1 equal D1, right? My reason would read line segments subtend equal angles on the same side, right? So let's look at some problems. Alright, so if you look here, I'm doing a problem from November 2013, paper 2, Eastern Cape, from a grade 11 exam paper, right? So given to us, they say in the diagram, chords AR and CP intersect inside the circle, and then I need to know that AC is parallel to TB. We have to prove that PDBR is a cyclic quad, so PDBR, that outside shape, is a cyclic quad. Right, so let's look at the solution. So 7 marks first. If you look at the shape inside there, I assume you can see there's an X there. No? There are my 2 green lines and the third green line. Those two are parallel. So first I can state that CAR, that angle A there, equal RPC. RPC, that angle there. So we go back with angle A. You see it's subtended by the arc CR. If I go back with P, P is also subtended by the arc CR. So therefore angle A equal angle P, angles in the same segment. Alright. At the same time, I have a parallel line. If you look at the line in between, they form the letter N or Z, which means they are alternating angles. So I can say CAB or CAR, whichever way you want to write it, equal TBA. Right, you see that angle there, TBA equal that angle there. Right, so therefore I can conclude then that RPC then, that angle is equal to this angle here, TBA. Right, so the exterior angle equal the opposite interior angle, so therefore PDR is a cyclic quad. You're allowed to specify an exam converse exterior angle of a cyclic quad, or proper, we would say exterior angle equal interior opposite angle. So because those two angles are equal, it makes this outside shape a cyclic quad. Let's look at the next problem. Alright, so this is a grade 11 problem that was in a prelim paper, September 2015, paper 2, Eastern Cape, question 9. They say in the diagram, O is the center of the circle, right? And they've extended there. We have DA, AC form a bigger triangle, and then I have EB, right? So look at first problem, give reasons for each statement. Why would we say that E1 equal X? And why would we specify that O1 equal 2X? So look, E1 equal X, we can say exterior angle of a cyclic quad. So there's my cyclic quad, E touching circumference, B touching circumference, C touching circumference, and D there. So that shape there forms a cyclic quad because I have 4 sides all touching the circumference. So this angle on the outside of the cyclic quad must equal the opposite interior angle. So exterior angle of a cyclic quad equal opposite interior angle, right? So E1 equal X, exterior angle of cyclic quad. Right, if we look at O1 and we look at C there in blue goes back to D and B, so it's subtended by that arc DB. If I go back with O1 ends at D and ends by B, and it's also subtended by the same arc DB. So therefore angle at center equal 2 times angle at circumference. Therefore O1 equal 2x. My reason angle at center equal 2 times angle at circumference. Right, now let's look at the next problem. Now they say if it's given that BE is parallel to CD, so BE there is parallel to CD, prove that AC, that line there in blue, is equal to AD. At the same time, they want me to prove that ABOD is a cyclic quad, ABOD is a cyclic quad. Right, so let's look at solution. So first we have to prove that AC, that line in blue, equal AD, the line in black. So I can say DCB equal B3, parallel lines, corresponding angles. See there they form the letter F in blue. At the same time, B3 is the exterior angle of a cyclic quad equal to the whole angle D. So B3 equals CDE equal X. So that angle is X and this one is X. Exterior angle of a cyclic quad. And therefore DCB equals CDE. Right? They both X. So AC equal AD. Right, so therefore if this is X and that is X, AC equal AD, and my reason would be equal angles subtend equal sides. So the side facing the angle and that side facing that angle, therefore must be equal to each other. Right, now we have to prove that ABOD is a cyclic quad. So ABOD there, that shape there is a cyclic quad. In the shape you should see there's no X. So that means I'm already cancelling theorem 4. So either I'm going to use theorem 5 or theorem 6, depending on whether I have an exterior angle or opposite supplementary angles. Now I know we already solved O1 in the previous problem. We got O1 equal 2x, angle at center equal 2 times the angle at circumference. We've proven that. At the same time, we also solved B3 as being equal to x, and E1 equal x, exterior angle of cyclic quad. So if E1 is x and P3 is x, so you see E1 there equals CDA or CDE equal x, corresponding angles. At the same time P3 has already been proven as x. Now I can find EAB. So if that's x and that's x, angles in a triangle must add up to 180. So EAB equal 180 minus x or minus 2x. So this angle and O1 are facing each other. If I add them together, they must add up to 180 for it to be a cyclic quad. So if I say EAB plus angle O1, I have 180 minus 2x plus 2x, minus 2x plus 2x cancel, and I'm left with 180. So ABOD is a cyclic quad, and we say opposite angles are supplementary. Right, so grade 11 compulsory question, and we still test it in grade 12. Now just look specifically at cyclic quad. In the videos that follow, we'll be looking at all the problems tested from theorem 1 to 6 before we look at our tangents. Hope you enjoyed the lesson. Please like, share, and subscribe.